Okay, so number 6, write in scientific notation. So part A, we just have 23,905,000. And so to write that in scientific notation, you just count the number of places you move the decimal until you get to the 2 here, right after the 2. So 2.3905,000, we don't need those zeros, times 10 to what power? So we moved it 1, 2, 3, 4, 5, 6, 7 times. So the exponent of 10 is 7. Right. So that's part A. Part B, we have 0.0000761. So here we're moving the decimal to the right. This is a small number, so it's going to get a negative exponent, right? So we want 7.61 times 10 to the negative, let's count, 1, 2, 3, 4, 5, right? So negative 5. Okay, for part C, we have 4.2 times 10 to the 25, divided by, that's supposed to be a 5, divided by 3.2 times 10 to the negative 89. Okay, so we can just do 4.2 divided by 3.2 times 10 to the power 25 minus negative 89. So 4.2 divided by 3.2. So if I multiply by 10, I just get 42 over 32. And if I divide by 2, I get 21 over 16. But I think at this point, I'm just going to use a calculator. So 21 divided by 16 is 1.3125. Right, and that's not an approximation. This is exact, right? So 1.3125 times 10 to what power? So 25 plus 89, I think, is 114. I'm just going to check that on my calculator. Yeah, 114. Right, so that's the answer. Sorry about that. That's the answer to part C. Right, and I think you can handle part D, but let's go through it very quickly. So this is 200 times 7.5 times 10 to the 11. So 200 times 7.5 is 1,500 times 10 to the 11. However, that's not scientific notation, right? We still have to move the decimal 1, 2, 3 more spaces to get 1.5. So notice what I did here. By moving it to the left, I divided by 1,000. So now I have to multiply by 1,000. 1,000 is just 10 to the 3. So 1.5 times 10 to the 11 plus 3 is 14. So 1.5 times 10 to the 14. Right, so number 7, you're just going the other way, right? We have this 4.07 times 10 to the negative 3. So this is going to be a small number. So we're going to move the decimal to the left 1, 2, 3 spaces. And that means we need 2 more zeros in front of the 4. And I like to put a 0 in front of the decimal. You don't have to, but it's helpful. 0.00407. Okay. For part B, we have 2.998 times 10 to the 8. So this is going to be a big number because it's a positive exponent. So here we're going to move the decimal the other way, right, to the right. So 1, 2, 3, 4, 5, 6, 7, 8. So we need to fill in the spaces with zeros. 5 zeros, right? So this is going to be, let's see, comma here, 299,800,000. Okay, part C, we're going to multiply 4 times 10 to the 3 times 5 times 10 to the negative 5. So we can just multiply in any order, right? 4 times 5 times 10 to the 3 times 10 to the negative 5. 4 times 5 is 20, and then 10 to the 3 minus 5 is just 10 to the negative 2. So 20 times 10 to the negative 2. So what do? We take the 20 and we move the decimal 2 times. So remember, negative 2 means it's a small number. We're going to move to the left. So this is just 0.2. Right. If you move to the right, you're making a big number. That would be a positive exponent. And finally, part D, we have, I forgot. So 9 times 10 to the 375 divided by 6 times 10 to the 372. Right. And these are really big numbers, but when you divide them, you get 9 over 6 times 10 to the 375 minus 372. Right. So 9 over 6 reduces to 3 over 2, and 375 minus 372 is just 3. Okay, so 3 over 2 is just 1.5 as a decimal, and times 10 to the 3. And yep, that's already in scientific notation, so we can leave that alone. Oh, I'm sorry, they don't want scientific notation here. They want standard notation. Okay, fair enough. So take the 1.5 and just move the decimal 3 spaces. We want a bigger number, so 3 spaces to the right. 1, 2, 3. So this will be 1,500. Okay, so yeah, 1.53 times 10 to the 10 times 10 to the 3 is scientific notation, and this is standard notation. So 1,500 is the answer here. Okay, moving on to number 8. Right. Part A, we have 14x to the 5 minus 10x cubed plus 6x divided by 2x squared. So because we're dividing by a single term, right, a monomial, we can just split this up as 3 separate fractions. Just make sure you know when you're allowed to do that, because we're only dividing by just 2x squared, right? Right, so 14 divided by 2 is 7. X to the 5 divided by x to the 2, right? It's not x to the 5 divided by 2, it's x to the 5 minus 2. Remember, you subtract the exponents. And 5 minus 2 is 3, so 7x to the 3. Minus 10 divided by 2 is 5. X to the 3 minus 2 is x to the 1. Plus 6, 6 divided by 2 is 3. And x to the 1 minus 2 is negative 1. Well, so if you're not allowed to have a negative exponent, then it's 7x to the 3 minus 5x plus 3 over x. And I know we did write negative exponents in scientific notation, but maybe in these problems it's not a good idea. On the other hand, I'm not going to be that picky about it. Either way is fine here. The point is, we usually don't see a negative exponent here in these problems. Okay, so part B is done pretty much the same way. And I know a lot of you can probably just do this in your head, but I'm gonna do it step by step here. I'm gonna split this up. 15a to the 4, b to the 5, all over 3ab to the 5, minus 21a to the 3, b to the 6, over 3ab to the 5, and then plus 12a squared b to the 7 over 3ab to the 5, minus 24ab to the 8 over 3ab to the 5. All right, so 15 divided by 3 is 5. A to the 4 divided by a is a to the 3. B to the 5 divided by b to the 5, well, it's just b to the 0, which is 1. Minus 27 over 3 is 21 over 3, sorry, is 7. A to the 3 divided by a is a to the 2. And b to the 6 divided by b to the 5 is b to the 6 minus 5. So b to the 1, I'm not going to write the 1, plus 12 over 3 is 4. A squared divided by a is a, and b to the 7 divided by b to the 5 is b squared. Minus 27, I'm sorry, I say 27 a lot. 24 over 3 is 8. A divided by a is 1, and b to the 8 divided by b to the 5 is b to the 8 minus 5, which is 3. Okay, so that's part B. Okay, 8D, we have 2x to the 4 minus 3x cubed minus 14x squared plus 19x plus 4 all over x minus 3. So the issue here is that this denominator is not a single term anymore, so we can't split this up, right? We have to do this by long division. So we're going to divide by x minus 3, and underneath we have the 2x to the 4 minus 3x cubed minus 14x squared plus 19x plus 4. Okay, so this is going to take a while. Let's just go step by step here. I'm going to try to do this slowly. So first you're going to divide 2x to the 4th by x. Well, that's just 2x cubed, right? Okay, and that's already the first term of the quotient. Then you multiply the 2x cubed by x minus 3. So when you distribute, you're going to get 2x to the 4 minus 6x to the 3. And then we just subtract, right? Now, the way I've been telling you to do this is I tell you to switch the signs and add, right? So make this a negative 2 here and make this a positive 6. Easier to add than subtract. 2 plus negative 2 is 0. You should always get 0 for the first term. Negative 3 plus 6 is positive 3, right? So positive 3x cubed. And then the other terms just come down, right? Negative 14x squared plus 0 is negative 14x squared plus 19x plus 4. All right, so now we go on to the second round where we take the 3x cubed and divide by x, and that's just 3x squared. So that's the next term of the quotient. So now we multiply 3x squared times, again, the entire divisor, x minus 3. And we get 3x cubed minus 9x squared. Yeah, that's it. And now we subtract, right? So yeah, 3 minus 3 is 0. That's clear. Negative 14 minus negative 9. Okay, so I hope you're not putting down negative 23 because that's wrong. Right? You forgot to flip the signs, right? Negative 3 and then positive 9. So it's actually negative 14x squared plus 9x squared, which is negative 5x squared. So don't forget to switch the signs here. Very important. Because otherwise, you'll just get the wrong answer. Right? And then 19x plus 0 is 19x. 4 plus 0 is 4. And now we're on to round 3. So now we take the negative 5x squared and divide by x. So that's just negative 5x. So we multiply negative 5x times x minus 3. And that's going to be negative 5x squared plus 15x. And again, now we're just going to switch the signs here. Instead of a negative 5x squared, it'll be positive 5x squared. Instead of a 15x, it'll be a negative 15x. So I got to erase the plus sign, make it a minus. And now we just add, right? Negative 5 plus 5 is 0. 19 plus negative 15, or 19 minus 15, is just 4, right? So 4x plus 4. All right. So now we're up to round 4, I guess. We divide 4x by x. So 4x divided by x is just 4. So take the 4, multiply by x minus 3, and you get 4x minus 12. Subtract, or better yet, flip the signs and add. So negative 4x plus 12x, right? And so 4x minus 4x is 0, and then 4 plus 12 is 16. Okay, so now we know we're done because there's nothing else to bring down here. 16 is the remainder, right? And then up here, this is the quotient, right? So the way to write the answer then is to write down the quotient, right? So 2x cubed plus 3x squared minus 5x plus 4. And then write the remainder, 16 divided by the divisor, x minus 3. Right. Yeah, remainder 16. But the last term here is 16 over x minus 3. All right, so I hope that helps. All right, number 9, factoring. Right, so there was a whole chapter in factoring here. So this hopefully is a good review of factoring. And I'm just going to start with part A here. 3x to the 4th plus 15x cubed plus 6x squared. Right, so remember what's involved in factoring. The first step is always to find the GCF, right? If the GCF is 1, you just move on to how many terms you have. If you have 4 terms, you factor by grouping. If you have 3 terms, well, you can always use the AC method, although there might be other ways of doing it. There are shortcuts sometimes. And if you only have 2 terms, well, those are called binomials, and there's only 3 ways of doing those. We'll talk about those later. So here we have 3 terms, but remember, before you do any AC method, you might want to find the GCF. The GCF here is just 3x squared. So you factor out the 3x squared, and when you divide, you get just x squared plus 5x plus 2. Now, can we factor this trinomial as the product of 2 binomials? So let's see. What 2 numbers multiply to 2 and add to 5? Well, 2 is just 1 times 2. And 1 plus 2 is 3, which is not 5. Right. So there's no match here. Right? You can also do negative 1 times negative 2, but that adds to negative 3, which is even worse. You're never going to get 5. So, yep, x squared plus 5x plus 2 is prime, so there's no way to factor that. Right? But be careful you don't write prime. The answer is not prime. The answer is this. Right? You still factored out the 3x squared. Right? This trinomial here is prime, but again, that's not the answer. Right? Okay. So, right, so that's part A. Part B, 4y squared minus 25. So this is a binomial, right? In this case, the GCF is just 1, so that makes it easy. So in this case, we're looking to factor this, because of the y squared, we're looking to factor this as the difference of 2 perfect squares, right? A squared minus b squared should factor as a minus b times a plus b. Right, hopefully you know that. So what's a and what's b? Well, right, 4 is just 2 squared, and 25 is 5 squared. So it looks like a is just 2y, and b is 5. So you can write those down if you find that helpful. Oops, sorry, I forgot that they're squared. So this is a squared minus b squared, right? So this factors as a minus b, oops, times a plus b. So a minus b is 2y minus 5. It's supposed to be 5. And then a plus b is 2y plus 5. And that's it. Right? Nothing else to do there. Right. Part C, a squared plus 3a minus 40. Okay, so again, the GCF is 1, right? Because there's a 1 in front, and right. So can we find 2 numbers that multiply to negative 40 and add to negative 3? Well, let's go through the list here. How many different ways are there to multiply two numbers to get negative 40? And notice we want them to add to a negative number, so we're going to make the bigger number negative, right? So 1 times negative 40 is negative 40. Right? 2 times negative 20 is also negative 40. It's not divisible by 3, but you can divide by 4. 4 times negative 10. Right? Or you can do 5 times negative 8. It's not divisible by 6 or 7 or 8. Well, it is divisible by 8, but then you just get negative 5. So at this stage, I think we're just going backwards here, right? So when we add 1 plus negative 40, we get negative 39. That's not negative 3, so no match. 2 minus 20, 2 minus 20 is negative 18, but that's not negative 3. No match there. 4 minus 10 is negative 6. Close, but it's not negative 3. 5 minus 8. There we go. That's negative 3. So the two numbers that go here are positive 5 and negative 8. And that's it. Again, order doesn't matter, so if you write a plus 8 times, I'm sorry, not a plus 8, a minus 8 times a plus 5, and that's also correct. Yeah, in fact, let me warn you that a plus 8 times a minus 5 is wrong. Right, because this would multiply to a squared plus 3a minus 40. So what's wrong with that? Well, not much, but this is a minus 3, this is a plus 3, so not the same thing. Yep. So don't switch the signs here, right? You can switch the order of the factors, but you cannot switch the signs. Right. All right, part D, 2x squared plus 7x minus 3. So the GCF here again is 1, right, because 7 is not divisible by 2 or 3. Right? But here a is 2, so this is going to be a genuine AC method, right? So for the AC method here, we're going to multiply a times c. 2 times negative 3 is negative 6. Right. What two numbers multiply to negative 6 and add to 7? So let's see, negative 6 is 1 times negative 6, or 2 times negative 3. All right. So 1 minus 6 is negative 5, and 2 minus 3 is negative 1. So those are not 7. And of course, we want a positive 7, so maybe let's make the bigger number positive. So negative 1 times 6 and negative 2 times 3. But when you add those up, negative 1 plus 6 is positive 5, and negative 2 plus 3 is positive 1. That's a 3, not a 13, sorry. But neither of these are equal to 7. And I don't see any other way to multiply two numbers to get negative 6. So after all that, right, this is just going to be prime. Okay. Right. So when there's no match, you just say it's prime. You can also say not factorable. I think that's what I have in the answer, not factorable. Technically, it is factorable, just not factorable over the rational numbers, and so that's all we care about here. Right. So part E, we want to factor 5x squared minus 45. Write that down. Okay, so GCF is not 1, GCF is 5. So let's factor out the 5. And now, x squared minus 9, well, this is also the difference of two perfect squares. 9 is just 3 times 3. Right? So a is x, and b is 3. So for a squared minus b squared, it's just a minus b times a plus b. Or in this case, x minus 3 times x plus 3. And then don't forget the 5 in front, the GCF, and that's part E. Right? So this was a two-step process, right? We have the GCF first, that's the 5, and then we have the difference of two squares. Again, Just to remind you, a squared minus b squared. For part f, we have x cubed minus 12x squared plus 36x. So the GCF here is x, so let's factor out the x first, leaving us with x squared minus 12x plus 36. Right. Now, can we leave it like that? Well, that depends on if we can factor x squared minus 12x plus 36. So let's try it. Are there two numbers that multiply to 36 and add to negative 12? So this is going to be, let's see, 36, we can do negative 1 times negative 36. We could do negative 2 times negative 18, negative 3 times negative 12, negative 4 times negative 9, and negative 6 times negative 6. So only one of these adds up to negative 12, and it's the last one, right? So none of these others will match with the negative 12. There's our match, right? So it's just x minus 6 times x minus 6. And in retrospect, we could have also factored this as a perfect square. X minus 6 times x minus 6 is just x minus 6 squared. So it's x times x minus 6 squared. Right? So yeah, just to remind you that you might want to use the perfect square trinomials. If we had done that, it might have been a little bit faster here. And here's the one for the plus signs. So again, helpful if you do know these, but in this case it wasn't necessary because we could do it the same way as we did the others. On the other hand, if you remember completing the square in chapter 11, you know that you might have to rely on these formulas here. So ideally you should know these as well. Okay, part G, AB plus 3A minus 5B minus 15. Again, don't forget to ask what the GCF is. In this case, it's 1, right? Because there's no A in the last two terms. There's no B in these terms, so we can't factor out an A or a B. And the leading coefficient is 1, so we can't factor out any numbers, right? Remember, when you're finding the GCF, you have to look for all four terms at once. On the other hand, this is a 4-term polynomial. So remember what 4 terms means. It means we look for grouping. So now we can look for factoring just the first two terms and just the last two terms separately. So from the first two terms, we can factor out an A. That's the GCF there. So A times B plus 3. And from the last two terms, we can factor out a negative 5. When we divide, we just get b plus 3. So this is going to work because b plus 3 and b plus 3, that's our common factor. Even though it's a binomial, we can still factor it out as b plus 3. And then what does the b plus 3 multiply? It multiplies the a and the negative 5. So a minus 5. And we're done. There's nothing else to do, right? Of course, you can change the order. You can do a minus 5 times b plus 3. Oops, sorry, that's a b, not a 6. But don't do a plus 5 times b minus 3. That would be wrong. Right. Okay, moving on to h. 9h, we want to factor 8z cubed plus 27. GCF is 1. Make a note of that. But these aren't perfect squares, right? These are going to be perfect cubes. 8 is 2 times 2 times 2, right? Or 2 to the 3 times z to the 3. And 27 is 3 times 3 times 3. So 3 cubed. So this looks like it's going to be the sum of two perfect cubes, right? You can think of this as a cubed plus b cubed, where a is just 2 times z, and b is 3. Okay, so in order to factor this, we have to know how to factor a cubed plus b cubed. Just to remind you, it's a plus b times a squared minus AB plus B squared. I know that's hard to remember, but you got to remember it. Right? All right, now just plug in A. A is 2z, B is 3. So A squared, 2z times 2z, is 4z squared, minus A times B. A times B is 2z times 3, so 6z, and then plus B squared. Well, B is 3, so 3 squared is 9. And so that's our answer. Right? Notice that we have this trinomial here. Can we factor it? I'm going to say no. Now, I didn't try it, right? I didn't use the AC method here. But I think I've warned you many times that there's no reason to try it, right? This trinomial here will not be factorable, at least for what we want to do here, right? And even if it is factorable, you don't want to do it, right? You're going to leave it alone. So this is our final answer. We don't need to try to factor the trinomials in this case specifically, right? This here will not be factorable. It will be prime. Well, and if it isn't, then don't worry about it, right? You can still leave that alone. All right. So moving on to 9i, we have 3w squared plus 11w minus 20. So this is a trinomial, three terms. GCF is 1 again. And what do we have? A is 3, B is 11, and C is negative 20. So I think we're going to have to use the AC method here. A times C, 3 times negative 20, is negative 60. So we need two numbers that multiply to negative 60 and add to 11. So it's a positive number, so I'll make the bigger number positive. So negative 1 and 60, negative 2 and 30, negative 3 and 20, negative 4 and 15. Oh, that's it, right? 15 minus 4 is 11. So we can stop there. The other numbers don't add up to 11. Here they are just for reference, right? Okay, so 11, right? It's going to be negative 4 plus 15. And in particular, if you multiply by w, right, negative 4w plus 15w equals 11w. So we're going to split up the middle term, the 11w, as negative 4w plus 15w. Right. And now that we have four terms, we can go back and factor by grouping, just like the one before this, right? Letter G, I think, was grouping, right? So factor out the w, and you're left with 3w minus 4. And for the last two terms, you can factor out 15 and 20, 5, right? So that leaves us with 3w minus 4 again. So the 3w minus 4 is our common factor. We can factor that out. And it multiplies the w plus 5. Good enough, right? So that's the answer to part I. Again, order doesn't matter, so w plus 5 times 3w minus 4 is just as good. Okay. All right, so moving on to the slightly more difficult ones. Part J, 4x squared minus 5x minus 12x plus 15. Once again, the GCF is 1, right? It's not always 1, but it seems to be for most of these problems here, right? And notice it's 4 terms, and so we can just factor by grouping again, right? So if we factor out an x, we get x times 4x minus 5. And from the last two terms, if we factor out a negative 3, we get 4x minus 5. So factor out the 4x minus 5 and multiply by x minus 3. And we're done. Right? Yeah, right? If you were not careful, you might have combined the negative 5x and 12x. You would have had 4x squared minus 17x plus 15. Now it's a trinomial, and now you would have to use the AC method. So you can do it that way, but you're making it harder because you're going to look for two numbers that multiply to 60 and add to negative 17. Well, we did that already. It would be 3 and negative 20. Right? So the point is you would have to split this up, right? Oh, I'm sorry. It's positive 60, not negative 60. 4 times 15 is 60. Yeah. The point is you would have to split this up, right, as negative 12x minus 5x or negative 5x minus 12x. But the point is that they gave it to you in that form already. So you're just making extra work for yourself, right? So look at the problem carefully and don't always just assume that you have to simplify this. I mean, you could have done it, but it would have made the problem a little bit harder, a little bit longer. All right, let's move on to 9k. Right, so we want to factor 2x to the fourth minus 16x. So the GCF is not 1 anymore, right? 2 and 16 are both divisible by 2, so we can factor out a 2. But notice that there's an x in both terms as well, so we can factor out an x. So the GCF is 2x. So let's factor out the 2x first. When we divide, 2 divided by 2 is 1. X to the fourth divided by x is x cubed. And negative 16x divided by 2x is just negative 8. Okay. Well, are we done? Not necessarily, right? Because this looks like a cubed minus b cubed. Yep, so it's another difference of cubes. And maybe I'm going to have to remind you of that, I guess. A cubed minus b cubed factors as a minus b times a squared plus ab plus b squared. This is one you should know by now. In this case, a is just x, right? And b is just, well, 2, right? Because this is x cubed minus 2 cubed. So we still have the 2x in front, but the a minus b is x minus 2. A squared is x squared, plus ab is x times 2, or better yet, 2 times x. And then b squared is 2 squared, but that's just 4. 2 times 2 is 4. Right? So there it is, right? 2x times x minus 2 times x squared plus 2x plus 4. Right? So again, a little bit harder because of the difference of cubes. Yep, you have to know it. And then finally 9L. 9L. So this is t to the 2 minus 9t plus 14. And GCF is 1. And a is 1. So what two numbers multiply to 14 and add to negative 9? Well, it's not negative 1 and negative 14. It's got to be negative 2 and negative 7, right? Negative 2 plus negative 7 is negative 9. So t minus 2 times t minus 7. Right. So yeah, not hard at all. Right? That one should be pretty routine at this point. All right, so moving on to number 10. Now we're solving equations. And part A looks difficult, right? It's 3x times x minus 2 times 3x plus 5 equals 0. But it's actually one of the easier ones because it's already factored and it already equals 0. So all we have to do is set each factor equal to 0. And I think you can solve all of these. Just be careful you don't subtract 3, right? This is not 3 plus x, it's 3 times x. So the opposite of times is divide. So 0 divided by 3 is 0. Now this is x minus 2 equals 0, so the opposite of subtracting 2 is adding 2. So 0 plus 2 is 2. So x equals 2. Here, first we subtract the 5, so 2x is negative 5, and then divide by the 2. So we're going to get x equals negative 5 over 2, or negative 2.5. So this one had three solutions, 0, 2, and negative 5 over 2. Except I just realized it's a 3, not a 2. All right, so let me back up a second here. So this is 3x plus 5, not 2x plus 5. Okay, so x equals 2 was correct. Yeah, so this is a, all right, let me write it here. 3x plus 5 equals 0, right? So subtracting 5, that part's okay. 3x equals negative 5. Now divide by 3, and so we get x equals negative 5 over 3, not negative 5 over 2. Sorry about that. All right, I think that's correct. Okay, so part B, we have t squared plus 6t minus 16. And it does equal 0, but this is not factored. So we have to factor it. And so what two numbers multiply to negative 16 and add to positive 6? So it's not 16 and negative 1. I think it has to be 8 times negative 2 is negative 16, right? And 8 minus 2 is 6. So either t plus 8 equals 0 or t minus 2 equals 0. So t is either going to be negative 8 or positive 2. And that's part B. Part C, we have y times y plus 1 equals 12. Okay, this is factored on the left, but it doesn't equal 0. So, right, so the fact that it's factored is not helpful, because we should subtract the 12 from both sides. Right? But that just means we have to multiply by y here. So y times y is y squared, plus 1 times y is y, minus 12 equals 0. Right, so now we put this in standard form. So it's in standard form. Now we just have to factor. So as usual, what two numbers multiply to negative 12 and add to 1? Okay, so it's not going to be 12 and negative 1 or 6 and negative 2. It's going to be positive 4 and negative 3. 4 minus 3 is 1, right? So y is either going to equal negative 4 or positive 3. Oops. Y equals positive 3. All right. Moving on to part D. We have x cubed equals 9x. And this is actually one of the more difficult ones because it's x cubed instead of x squared. Right? And it doesn't equal 0, so if I subtract the 9x from both sides, now I get x cubed minus 9x equals 0. So how do we factor x cubed minus 9x? Let's start with the GCF. The GCF is x, so factor out an x, leaving you with x times x squared minus 9. However, x squared minus 9, as we saw earlier, is just, x squared, is just the difference of two perfect squares, right? 9 is 3 squared. So I can factor that a squared minus b squared as a minus b times a plus b. So the three factors here are x, x minus 3, and x plus 3. When you set them equal to 0, we again get three solutions instead of two. We get 0, 3, and negative 3. Okay, and part E is a lot like part C. We have to subtract the 3 and multiply out the u's here. So this is going to be 4u squared minus 11u equals 3. So subtract the 3 from both sides. 4u squared minus 11u minus 3 equals 0. And this is, again, a quadratic equation at this point. You could use the quadratic formula. You could complete the square, although I wouldn't recommend it. That would be the most difficult way to do it. And it looks like we might be able to factor this. So unfortunately, this is by the AC method, right? You can't just say what two numbers multiply to negative 3 and add to negative 11. Right, so a times c, 4 times negative 3 is negative 12. So what two numbers multiply to negative 12 and add to negative 11? So luckily, it's just negative 12 times 1. It's the first one you would probably try, because negative 12 plus 1 is negative 11. And so, so we're going to have to split this up, right? AC method. So negative 11u is just negative 12u plus 1u. And when you factor it by grouping, you split it up. You factor out the 4u, and you get u minus 3. This is plus 1 times u minus 3. So you factor out the u minus 3, and the other factor is 4u plus 1. So this is 4u plus 1 times u minus 3. And now you just set the factors equal to 0. And sure enough, you get u is negative 1/4, or u is positive 3. Okay, so that's part E. And finally, part F. All right, probably the hardest one. But we just multiply by 2 here. So 2x squared plus 12x plus 8 equals x plus 3. But remember, the right side has to equal 0. So we're going to have to subtract the x from both sides, as well as the 3. So on the left, we get 2x squared plus 11x plus 5 equals 0. Okay, so this is again an AC method, although I'm going to do this rather quickly. So let me give you a little bit of time here to factor x squared plus 2x squared plus 11x plus 5. Yep, it's just going to be 2x plus 1 times x plus 5. Right. How did I get that? Well, I kind of guessed, right? I mean, there's really only two possibilities here. It's either that or 2x plus 5 times 2x times x plus 1. And that doesn't work out because you're going to get 2x squared plus 7x instead of the 11x. So yeah, I happen to guess this. But you really should use the AC method unless it's that obvious to you, right? So 2x plus 1 equals 0 gives us x equals negative 1/2, and x plus 5 equals 0 gives us x equals negative 5. And so those are the two solutions for part F.